And there was also a big eruption of a volcano in, I think, 1700.
Right, it's very clear that stratovolcanoes that put a lot of sulfates in the stratosphere cool the Earth for 2 or 3 years. We've got very good records of that. We could see it with Pinatubo, for example, when instrumentation was good. But there's indirect evidence for many earlier volcanoes when instrumentation wasn't around. So yes, that's sort of the idea of the geoengineering. They're going to put artificial volcanoes all over the world. I think it's absolutely insane. I hope that the good people of the world have enough sense not to let that happen.
Can you please explain these artificial volcanoes? You're talking about geoengineering.
Well, most geoengineering proposals are, as I said, to mock up what happens with volcanoes. And so they fly very high altitude airplanes or rockets, and they release something that forms particulates at high altitudes and reflects sunlight. And so you sort of cover the whole Earth with air pollution, and artificial air pollution that the government has paid for, the taxpayers have paid for, and it cools the Earth the way a volcano does. So that's the basic idea. It's not a crazy idea, I suppose. Maybe you could do it. It would be horrendously expensive, and it would be much more harm than good.
Are they doing this only in the United States or even outside? I'm asking for European Union, of course.
I don't think anyone is doing it. There's just lots of talk and lots of research on it, but I'm not aware of anyone seriously trying to do it.
Okay. Well, what other impacts has there is a multi-decade Atlantic variations. There is also decade Pacific variations. Can you explain us their impact on climate?
Could you say that again?
What other impacts on climate? I know that there is a multi-decade Atlantic variation and also decade Pacific variation. Can you explain us?
Understood, yes. Of course. Well, of course, the Earth is 70% of the Earth is covered with oceans. And the oceans have an enormous amount of heat, which they can absorb and release. And so anything in the oceans will affect the whole world's climate. And the most dramatic are the El Nino episodes every 4 or 5 years. The Pacific Ocean warm water sloshes back toward the Americas to South America. And that affects the climate all over the world, not just the Pacific Ocean, but Europe, America, Africa. And then there are longer term things like the Atlantic oscillation that you just mentioned, which involves transport of water north and south in the Atlantic, along the meridians, they call it, right? North and south, instead of east and west, as in the Pacific. And then there's a similar Pacific decadal oscillation that is north and south in Pacific. All of these things are important. They're not terribly well understood. They haven't been recorded terribly well. We're only just beginning to get the instrumentation out that allows us to understand them precisely. All we had 100 years ago were sporadic ship records. It just wasn't enough information to know about these natural events.
There is the biggest one, and maybe the most important one, greenhouse gas, is water vapor. That means they are making clouds. How these clouds have an impact on climate?
Well, you're right that water in all of its form is by far the most important driver of climate. So water affects climate in 2 ways directly. One is the greenhouse gas, water vapor. It's about twice as effective as CO2. So just the water vapor alone is very potent. And secondly, clouds are enormously important. Most of the Earth's albedo is clouds. It doesn't much matter what you do to green fields or forests. That's not going to compete with clouds. And so clouds, if they're low clouds, they reflect sunlight and they keep the Earth a little bit cooler. There is also the possibility of having very high cold clouds, cirrus clouds they call them, and they tend to warm the Earth a little bit. So clouds are very complicated. They can cause both warming and cooling, but I think on balance they're more likely to cause cooling. All the evidence is that clouds are a cooling mechanism.
Also, there is an impact from side of sun on clouds. Activities of sun and radiation have impact on making clouds more or less and cloud layer around the world. Can you explain this?
Yes, there's been a lot of very interesting work led by a Danish physicist, Hendrik Svensmark, and his Israeli partner, Nir Shaviv, on the effect of cosmic rays on the Earth's climate. And it's a complicated, not terribly complicated, but a little bit complicated idea. The Earth is always bombarded with galactic cosmic rays that are ionizing the atmosphere. But these can be deflected by the sun's magnetic field. So when the sun is very active, it ejects large loops of magnetic field out into space as far as the Earth's orbit and beyond. And they scatter the cosmic rays. So we get less cosmic rays when the sun is active. And the cosmic rays nucleate clouds. You know, you need something for water vapor to condense on, and cosmic rays provide ions to let that happen. And so, you know, one of the earliest instruments in physics was called a cloud chamber, where you would supersaturate a gas, and then when a radioactive particle would go through it, you would see a little trail left by the ionization. And the Earth does that too. So anyway, Svensmark and Shaviv have been working hard on that. And I would say that the jury's still out on whether it's a correct hypothesis or not, but I think it looks very promising. And I hope that they will continue their work. But certainly, you know, we talked about this Maunder minimum in the Little Ice Age in the 1500s and 1600s when there were no sunspots. And that would be consistent with more cosmic rays at that time, more cloudiness, because the sun was not shielding us as well. The sun may have been putting out just as much heat, but not as many magnetic fields, you know, to keep down the cosmic rays.